After soldering over 490 components, I finally got this circuit to work. And yeah, the cut-up mouse served us well, but it's time to upgrade to an actual USB cable. When I give this circuit power, I've hardwired some inputs here, where this would be the value stored by the A register, and this would be the value stored by the B register. The 7 red LEDs show what operation we want the ALU to perform. These yellow LEDs show us the output the ALU is producing. And these 4 LEDs here tell us some extra information about the output. For example, right now this means the number is greater than 0. Now with these control signals, we can change this operation because right now it defaults to addition. So 3 plus 1 is 4 in binary. We can tell it to ignore the A value, which then makes the operation 0 plus 1, and we get a 1 on the output. We can also tell it to ignore the B value, so it'll be A plus 0, which gives us the value stored in A. And if we ignore both A and B, we get 0 plus 0, and that's 0, and this tells us that the value is 0. We can also add 1 to the final result. So 3 plus 1 gives us 5. We can also completely change the operation from addition to an XOR. So this XORed with this gives us 2. We could also make it a logical AND operation. So we expect just the lowest bit to be on, and that's what we get. We can also make it a logical NOR operation, and I expect just the upper 2 bits to be on, and that's what we get. So you can combine these control signals to do a whole range of logical operations. You can negate B and add 1, and that gives you 3 minus 1 is 2. You can ignore B and add 1, and that will add 1 to whatever is in the A register. This will be important for some stack operations later on. Speaking of the stack pointer should also be able to decrement, meaning to subtract 1 from its value. So say for example I have a 7 in the stack pointer. Now 7 plus 1, it defaults to addition, we get an 8. So if you want to subtract 1 from this, and you don't want to affect the value in the B register, all you have to do is ignore B, then negate B, and as you can see, this combination subtracts 1 from the A register, no matter what the B input is. There are a bunch of different combinations of these control signals that you can use to perform a wide range of these logical functions.